Hi, I'm Josh Weiner, Senior Sales Manager here at Digital Globe. Every day I get asked the question, what is the best imagery to use to see our changing planet? And the correct response is always that it depends. Thousands of satellites, airplanes, helicopters, and drones collect images of our changing planet every day. But to determine which is best, you have to consider what you're doing with that image and which capabilities are most important. We make sense of all these different sensors by benchmarking a few key capabilities: spatial, spectral, and temporal resolution, and accuracy. Think of spatial resolution as how far you can zoom in, spectral resolution as what can be seen within each pixel, temporal resolution as how far back in time we can look and the currency of our freshest image, and accuracy as how close an object is to where it's actually represented in an image. Satellites offer the unique benefit of continually imaging our planet as they orbit and capture changes every day. From the famous blue marble image taken by Apollo 17 astronauts in 1972 to this high-resolution image taken of Complex 39 at the Kennedy Space Center, the launch site of the Saturn V rocket that pushed Apollo 17 to the moon. A lot has happened in the 45 years since that blue marble image was taken. The human population has nearly doubled, technology has grown exponentially, and our fascination with space has never been stronger. Today, there are more than 1,100 active satellites in space, orbiting at different altitudes, phases, and speeds, with sizes ranging from a shoebox to a school bus. Many of those satellites were launched to provide that bird's-eye perspective Socrates was in search of. At Digital Globe, we have 4 active satellites in orbit, with a 5th planned to launch in the fall of 2016. Each satellite maintains a sun-synchronized low Earth orbit. At roughly 400 miles above the Earth's surface, they circle the poles once every 90 minutes. Imagine taking crystal clear images like this one from a camera traveling 15,000 miles per hour. As the satellite completes an orbit, the Earth has rotated roughly 1 time zone beneath it, which maintains imagery collection time of between 10:30 a.m. and roughly 1 p.m. local time. That's when the sun, our flash, is the highest in the sky and shadows are minimal. Because our satellites are so agile, we can create dynamic collection plans that minimize clouds and maximize the collection of useful images for each orbit. Other Earth observation satellites, such as those supporting the USGS Landsat mission, are in a continuous collect mode and offer a guaranteed image of every inch of the planet every 7 or 8 days, however with a lower spatial resolution. These collections are highly complementary to Digital Globe's, as we often leverage lower resolution, continuous collect sensors to identify areas of change, and then collect those areas with the high resolution constellation. But once the imagery is collected by the satellite, you're only halfway home. The data is then downlinked to ground stations around the planet, piped back to Colorado for processing and hosting, and made available to our users within hours of collection, enabling them to make timely, critical decisions.